Somewhere beneath the forests of Europe, behind reinforced concrete, inside the cold ribs of a World War II bunker, there was a lock, not digital, not wireless, no fingerprint scanner, no Bluetooth handshake. And yet, it solved a problem that modern smart locks still struggle with. How did engineers in the 1940s design a system so psychologically clever, so mechanically ruthless, that it could outsmart today's smart security? Let's descend. During World War II, military engineers across Europe, from Germany to France and the United Kingdom, built hardened bunkers designed to withstand artillery, sabotage and infiltration. Concrete walls several meters thick, blast doors weighing hundreds of kilograms, air filtration systems, independent power supplies. But here's the question few people ask. When the bunker is built to survive bombs, how do you design a door that survives betrayal? Modern smart locks promise convenience. Open with your phone. Unlock remotely. Temporary digital keys. They rely on software, on electricity, on connectivity. And every one of those is an attack surface. Signal interception, battery failure, firmware exploits, social engineering. Now, just imagine you're a 1940s engineer. No Wi-Fi, no cloud servers. But, well, absolute paranoia. Because the enemy isn't just outside. They might be standing right beside you. One of the most fascinating bunker security systems was built on a principle so simple it feels almost insulting. The door did not rely on a single point of truth. It required multiple simultaneous human actions, performed in physical coordination, under strict procedural timing. Sound familiar? It should. This concept later evolved into nuclear launch protocols. Inside certain World War II command bunkers, entry required a mechanical key, a rotating combination dial, a pressure release sequence, and sometimes two operators acting at once. But here's the twist. The door mechanism wasn't just layered, it was interdependent. If one step was performed incorrectly, the entire system reset. Not electronically, mechanically.
Modern smart locks often use fail-safes. Battery dies, use a backup key, software glitch, reset remotely. Convenient. But, convenience is a vulnerability. WWII's bunker engineers, they optimize for something else. Irreversibility. When a bunker door sealed, massive steel bolts slid horizontally and vertically into reinforced sockets embedded in concrete. Not just one bolt, sometimes 6, sometimes 12. Even if you destroyed the external handle, the locking bars were already embedded deep inside the frame. And here's the genius part. The mechanism was shielded inside the door slab itself, often 10 to 15 centimeters of solid steel. No exposed motor, no access panel, no firmware port. But the real hack wasn't the steel. It was human psychology. In some installations, guards did not know the full unlocking sequence. One knew the key timing. Another knew the dial alignment. A third confirmed internal pressure balance, compartmentalization. If captured, no single person could open the bunker. Today, cybersecurity experts call this zero trust architecture. W2 engineers simply called it survival.
Now, compare that to modern smart locks. There's just a single admin account, a master reset, and, well, an app vulnerability. Hackers don't break steel anymore. They break trust, and trust is invisible. Consider this. A World War II bunker door does not care about signals. It does not care about passwords. It does not care about spoofed credentials. It responds only to physical, synchronized, irreversible motion. No electricity required. EMP-proof. Signal jamming is irrelevant. Remote hacking? Impossible. Unless you physically breach reinforced steel designed to withstand explosives. And here's where it becomes almost conspiratorial. In an age where we celebrate smart everything, why are we replacing hardened mechanical certainty with networked uncertainty? Is it innovation or dependency? Engineers in World War II understood something modern design sometimes forgets. The more complex a system becomes, the more ways it can fail. Mechanical systems degrade predictably. Digital systems fail unpredictably. A bunker lock jams. You feel resistance. A smart lock glitches. Well, it may unlock without you even knowing. Which is truly safer? There's another layer to this. Bunker doors often created airlock chambers. Two sequential doors. Even if an intruder breached the first, they were trapped between reinforced steel. No line of sight, no easy retreat. Modern smart homes. Single entry points connected to cloud-based authentication servers. Convenience compresses layers. WWII engineers expanded them. These systems were built without assuming loyalty. They assumed compromise. They assumed infiltration. They assumed betrayal. So they engineered against it. Today, many smart security systems assume compliance. They assume secure networks. They assume firmware updates will fix vulnerabilities. Assumptions are attack vectors. Picture this. A 1943 bunker, power grid destroyed, communications cut, under bombardment. The lock still functions. Now imagine a modern smart lock. Router offline. Cloud authentication down. Battery drained. Which door opens? The hack wasn't a trick. It was a philosophy. Eliminate remote dependencies. Separate knowledge. Require coordinated physical presence. Design for failure, not convenience. And here's the irony. Modern high-security facilities, data centers, military installations, vaults, still rely heavily on mechanical redundancies layered beneath digital systems, because when everything else fails, steel still works. This doesn't mean smart locks are useless. It means progress isn't always linear. Sometimes the past solved a problem so completely that we only rediscover its brilliance decades later. The WWII bunker door wasn't smart. It was strategic. It understood human weakness. It understood mechanical permanence. It understood that true security isn't about access. It's about control. So here's the unsettling thought to carry with you. In a world racing toward automation, are we engineering resilience or outsourcing responsibility? The engineers of the 1940s built for siege, sabotage, and worst-case scenarios. We build for seamless user experience. One mindset survives war, the other survives app reviews. Next time you tap your phone to unlock your door, ask yourself, if the power went out, if the network failed, if someone wanted in badly enough, would your lock outsmart them? Or would a 1940s bunker door do better? History doesn't just tell us where we've been. Sometimes it quietly shows us what we've forgotten.